All right, so hey everybody, welcome to the talk today on Project Aquarium. My name is Alexandra. I am the software engineering manager at SUSE, and for the purpose of Aquarium, I'm also the product owner. Joao?
And okay, I'm a senior engineer at SUSE. I've been working with the Ceph project for quite a bit of time. And for the purposes of Aquarium, I'm the backend lead.
Alrighty, so we're going to go through today what is this Aquarium thing? Why are we doing this? What is our objectives? How are we going to do this? We're going to go through a little demo. To clarify, this demo is pre-recorded because we don't trust demo gods. And then we'll just have a quick recap on what our outlook is, next steps, where we're going, what our plans are, and if we have time, we'll have a little Q&A. Alrighty, let's dive in. So what is Aquarium? The million-dollar question. So Aquarium is a open source project. The storage team at SUSE, who previously worked on developing the SUSE Enterprise Storage product, has now been working on a new approach on Ceph development and deployment, and management. This is an opinionated version of a storage appliance. And to be completely frank, we're still working on what that opinion is. You know, we're constantly developing and iterating this definition. But we do know we want this to be something that can provide and manage data without an application context, just mostly to add simplification to the day one installer experience. So we've split this into two clearly defined work streams at this point. They're relatively obvious and you'll get the sense for the theme, but we're going for Gravel, which is our back end, obviously the base layer of the Aquarium, and Glass, which is our front end, what you look through, how you're going to check out the Aquarium. And to be completely honest, we're really enjoying our own theming. So yeah, all right. Why are we doing this? Well, the perception is that Ceph is too complex to use for the average user. And this is some feedback we've received a lot, being part of the Ceph community as a Ceph product for such a long time. And this complexity stems from Ceph's flexibility, which supports such a huge matrix of use cases. And this has on the available capacity, performance, and availability. All current management tooling deploys Ceph bottom-up. So the user must specify deployment patterns at the daemon level, create pools and crush maps, and then only then can the user deploy their workload. So this project is basically exploring if other user interface abstractions are practical and ultimately an improvement. We believe in abstractive, complex concepts with simple terms. So our main goal is simplification, where a user is not required to configure individual daemons or disk layouts, but we can provide a high-level specification of what they want in terms of availability, usable capacity, basically that translates this all into a deployment layout. We also believe in a really tight naming scheme, so I think that's always worth counting out. Alrighty, architecture with Joao.
Okay, so the way we've been architecting...
I'm sorry, this has gone the wrong way. What?
Okay, that's fine. Okay, so Aquarium itself is a Python backend serving an Angular frontend. It's basically a system service. We start Aquarium on boot, and start Aquarium on boot, and we've chosen not to containerize this because Aquarium will be relying on tools like Ceph ADM and other host system binaries. So containerizing it would make everything a bit weird. And the purpose of this system service is mostly to manage and monitor Ceph and to do some deploying we need. Can you go to the next one?
Mm-hmm.
Aquarium itself will be running on every single host in the system, so it's essentially a cluster on top of a cluster, which is always fun. The nodes, should they need to communicate with each other, they will do so over WebSockets, mostly because the framework we are using for the HTTP backend already supports WebSockets, and it was just easier. We keep persistent state that we might need to share between the several hosts, several Aquarium nodes. we use etcd to keep that state, mostly because etcd does what we need, but also we didn't want to implement, on top of the fact that we are already having a cluster, having to also implement a consensus algorithm and a key value store and all of that. So we just leave etcd deal with that instead of having to implement that ourselves. And this way, we don't have the concept of a follower node and a leader node, and each node can serve the front end to the user without any particular constraints. While Aquarium itself is a Python backend and the Angular front end and all of that stuff, it runs as a system service. It runs from an image that we have been specifically building. This is meant to be a Tumbleweed-based RAM disk, which is meant to be run directly from a USB stick or to be PXE booted. This image is where Aquarium lives. It starts on boot, and if we reboot it, Aquarium makes sure that all the persistent state is kept on a system disk that is created upon deploy. But mostly this is meant for the upgrade path, so that upgrading Aquarium does not mean reflashing a disk or upgrading an OS. It just means changing the image and rebooting the server. At least that's the hope. The hope is that this will make upgrading Aquarium easier and dissociate Aquarium from upgrading Aquarium from upgrading Ceph. As Alex mentioned, we have these two work streams. We have the front end being Glass, back end being Gravel. Gravel itself has three major components to some extent. One of them is dealing with the local node on which that particular service is running. And we'll keep track of disks, CPU load, things like that. That might be interesting to have access to and are necessary before we actually deploy the initial node or deploy that node, before Ceph ADM actually has access to that information. We have a component that deals with all the operations within the Aquarium cluster. May it be deploying the initial node or having nodes joining the cluster. And we have this resource abstraction module-ish that can basically translate Ceph concepts into something that the web front end can consume in a fancy manner, so that these resources can be abstracted to the user. On top of this, all sits on top of Librados, essentially, Python Librados, which we then use to communicate with Ceph, and Ceph ADM, the Ceph ADM binary. Alex, can we move to the next one? Regardless, the front end is the one thing that people will be facing and be consuming. We aim at having an easy and guided install and having a cluster working from the first node. We are abstracting these concepts, like we don't have pools or gateways. We are offering services. We offer a file service, which can have multiple backends. And we intend at some point in the near future to have like use case driven deployment, in the sense that the user will be specifying a set of wants the system, and the system will be providing a solution on feasibility or whether that use case is feasible given the existing resources in the cluster, or even given the node and the existing resources. I think this is demo time. Yeah.
All right, switch it up. Let's see how we go.
Okay. Let me see if this. Okay, so as mentioned before, this is a pre-recorded demo. See the whole thing?
Mm-hmm.
Okay, cool. So to start, this is a web browser. We are connecting to, in this case, it's a VM. We are connecting to Aquarium. And when we connect to the host at the specified port, we will get this splash page welcoming the user to Aquarium. Moving on, we will go through a guided steps. We are creating a new cluster. We are going to be asking the user for the node's host name. And after that, we get to decide whether we want to use a self-hosted NTP server or something from the internet. Oops. What happened?
Oh,
Sorry about that. Yeah. we get to see like the devices that we have available, which was not clear enough. But essentially, the service will pick a solution for the disks that we have available, choosing one of them as a system disk where we will persist all the data we need to persist. We can then add the services we might want, or we can wait to do that from the dashboard. We get immediate feedback based on the resources we have available, maybe the number of replicas or the capacity that they have available. And at this service, as it is being deployed, it is creating the pools in the backend and calling all the necessary bits and bobs and stuff, so that we get a fancy dashboard. Well, it will be eventually fancier, but right now it's providing the information that we actually need in terms of services, the hosts we have available. Extending the cluster will require adding a new node to the fold. For that, we will need to choose a join existing cluster, set up the host name, and we will need the IP address of an existing server, any existing server, and the authentication token that we have generated upon initial deployment. This process is fairly quick to achieve. Basically, we are just registering one node with the existing cluster and adding that to Ceph via the Ceph orchestrator. We have taken a bit of creative liberty here and cut all the boring parts between then and now. But you can see that the system shows the existing both hosts on the newly added host, and we can add a new service from the second host, and it will show up in the first host as well. So both nodes are basically being able to perform tasks and see live data in the cluster as they are operating. It's a bit irrelevant from which node you are actually doing anything. And this bit here is just to show that we actually can write data to the cluster. We provide you with a helper to mount points for each service in this case. And in the background, we've got a script that is going to be writing data to this cluster. and we keep track of the reads and the writes performance based on services instead of pools, because that's the abstraction that we are offering. Okay, so that's about it for the demo, right?
I believe so.
Yeah, that's done. Yeah.
All right. So what's next? I think what we've got is something pretty exciting, but we still need to really be thinking about where we're going from here. It's a project, it's new, it's budding. So in the short term, we're going to focus largely on dashboard improvements, getting the object service up and running from a USB 6 and Pixie booting on real hardware. And to be honest with you, tests, lots of tests. We're working on an extensive testing plan to get ourselves up to scratch. I think one of the most important things is testing, and that's always been such a high bar in the Ceph community, and that's something we want to keep following along with. In the medium term, upgrades are going to become a priority, block service and resource constraint solver. And the long term, world domination, obviously. No, our priorities going forward are going to be community development. We want to be, this is a passion project for our team, and we want to be open and honest with everybody who wants to get involved. We're here for a good time, and a long time is a bonus. We're very proud of how far we've come in such a short period of time. We started this project in January, and we've been working with some seriously amazing engineers, and we're open to anyone and everyone coming to check out what we've got, where we're about, and provide some feedback. We do, as I've put there, have a developer roadmap. This is just sort of a glance at all the things that we're really hoping to achieve over the next, I think we put 7 or 8 milestones. Joao can correct me if I'm wrong there.
I think we have about 8 milestones.
8 milestones. Cool.
Kind of in there, but subject to change.
Subject to change, indeed. Cool. So that's us. Our project is open. Links are here, or you can contact either one of us or anyone in the storage team for more information. We're on Slack. We've got GitHub discussions board. We meet 3 times a week to manage as many different time zones as possible. So we do one that's more for APJ, one for Europe, one for the Americas. We have a basic getting started guide from zero to hacking, and we'd love to see what people think. So thanks very much. I can probably stop sharing my screen if anybody had any questions.
Yeah, Ernesto here, Ceph Dashboard team. I'm interested in knowing what are the lessons learned from the dashboard experience, Ceph Dashboard compared to this one.
I'm sorry. Can you say that again?
Yeah. I am interested in knowing your lesson learned or how you apply them to this from the past experience with the Ceph Dashboard.
Okay.
That is a really good question, and I do wonder if we have one of our dashboard engineers on the call. Is either, I think Volker's here and so is Tatiana. Do you guys mind speaking up to that?
I think that's really hard to compare because the projects and the ways we are going are really different.
Right. I think in parts the thing is that we are trying something that is slightly different while taking into account that the Ceph dashboard is something to behold in terms of not only the information it shows the user, the usefulness of that information, but also the level of detail. And that's something that we are trying to some extent abstract while factoring in factoring in the bits that are most useful without actually copying the existing dashboard, right? Because we don't want this to be competing with the dashboard, because I think they follow 2 different approaches, at least at this moment in time. And they are, or at least we are hoping that they are helpful in two different contexts. One in which we want to have access as much of Ceph control as possible, and another where we can afford to relinquish some control and just use abstractions and whatnot. But again, we are still in the middle of figuring a lot of this out. Most of this has been a learning experience and trying whether this works out and whether it doesn't. Unsure if this actually answers your question.
Yeah, kind of. Thanks. One extra question. Is it possible then to switch or jump from this the Aquarium dashboard to the Ceph dashboard as a fallback mechanism, or is it completely hidden and there's no way to?
At this moment, the dashboard is disabled, mostly for, well, to reduce the amount of things that we have to factor in. But I think that would be something that might be useful, even if it's eventually for someone who either wants more control or maybe to even debug things in case they break. Again, everything is a bit open still.
Thank you, folks.
I have a similar question. I guess I was about to ask if the front end is making use of the dashboard backend API in order to get its visibility of the cluster and whatever to manipulate it. So if it's disabling the dashboard module, I'm just curious what how it is that you're interacting with stuff itself.
We're doing Python librados. Mostly, initially we actually attempted to use the dashboard API, but we realized that a lot of that API is targeting the dashboard itself and not necessarily, or at least it's not in a state yet to be an API to Ceph. And as such, we chose to go with Python librados and actually issuing commands directly to the manager and the monitors. Hopefully at some point this can change, because personally I'm not a big fan of that. But this has been the approach we've been taking.
I had a different question about the hardware side of things. Are there are you targeting particular models or of hardware for the service themselves, or is this meant to sort of run on anything? I'm just curious if the goal here is to have like an opinionated appliance that you deliver with like known SKUs or something like that, or
so that's one thing we've been discussing. How opinionated we want to be. One of the things might be eventually to decide that we are opinionated about the number of disks, for instance, or how much CPU one needs to have, RAM and whatnot, and be a bit more strict about it. If the tricky thing about deciding on the actual hardware is that, first of all, one would have to have access to the hardware to actually, validate it. And on top of that, that seems a bit out of I don't know. It can be tricky overall. But I don't think at this point in time we are looking for specific vendors, models, whatever for the hardware.
Yeah, I mentioned earlier that we're still discussing a bit about what opinionated means, and honestly, that's part of the question. And I think that's something that as much as it's quite like a double-edged thing, right? Like as much as we can say, yeah, this is exactly the kind of SKUs, this is the way we want things to go, we do recognize that it's an open source project, right? People can take that and do what they want with it. So it all really sort of depends on the future. And I would probably say after this year, I think we might have a better idea of where we're going with regards to hardware. But it's going to take some time and probably a lot of thought.
Oh, okay. A question. What's the benefit of also deploying etcd?
So the idea, at least we've been operating on, is that Aquarium needs to work regardless of Ceph. So if we have a Ceph outage, Aquarium needs to still be working, be able to at least eventually help the user to recover the cluster. And as such, we cannot rely on, for instance, the monitor p-value store to store data that we need to operate Aquarium. As such, we need something that is not in Ceph to keep that state. And the benefit of etcd is that it already has a consensus algorithm and already is able to function in a clustered way, so that we don't have to implement that in Aquarium.
Okay.
Make sense?
Yeah, makes sense. I was wondering why.
Any more questions? All right. Well, thank you, Joao and Alex, for presenting on Project Aquarium for the community. Do we go to Woot? Well,
Hey, Mike.
hey.
Hey.